So, hello students. Today we are going to discuss velocity of image in mirror. Plane mirror and spherical mirror both will be covered in this lecture. It will be almost 1 hour lecture where we'll cover all types of velocities of images in plane mirror as well as in spherical mirror. So, let's start with plane mirror. Plane mirror. So, if we have a plane mirror here, assume that this is a mirror and any object is kept here. This is our object. This is our object. We all know if we draw a perpendicular line on the mirror passing through the object, so image will also lie on the same line. Image will also lie on the same line. This is our image. And we also know this distance is distance of object. We call it u, and this distance is distance of image. We call it v. We also know u is equal to minus v, means both have opposite direction and equal magnitude, or we can write modulus of u is equal to modulus of v, means their direction will be opposite. Why direction is opposite? Because we measure all the distances in mirror from the mirror. Like here in this case, this is our 0, 0, 0, this point. All the distances will be measured from this point. And if object is here, so ray will go on the mirror in this direction. So this direction will be taken as positive. Direction in incident ray is taken as positive. So here v will be positive and u is negative. Object distance is negative and image distance v is positive. That's why u and v both are having opposite sign. U is equal to minus v, or we can write modulus of u is equal to modulus of v. Now, since we already have u is equal to minus v, now suppose that this object O started to move either in this direction or this direction. So what will happen? The image will also move, and when object and image both are moving, in that case u and v both will become variable. They are no more constant. So if they are variable, means with time u as well as v both are changing. So now if we take derivative of u and v with respect to time, so take both side derivative. So du divided by dt is equal to minus dv divided by du. Here u is object distance, v is image distance. Now, if we write VO as object velocity, u is variable. So, du by dt means when we take derivative of object distance from the mirror, so it will become velocity of object is equal to Vi is image velocity. So, when we will take derivative of V means image distance with respect to time, we will get velocity of image with a minus sign. Now, just think, we have measured u and v from mirror. Here I explained you this object distance u is measured from the mirror. This image distance v is also measured from the mirror. So when we'll calculate du by dt, we'll get velocity which we call vo. Actually, this velocity will not be in ground frame of reference, but it will be in mirror frame of reference. So this velocity du by dt is not velocity of object with respect to ground, but it is velocity of object with respect to mirror. Similarly, this v means image distance is also measured from the mirror. So this distance is also not with respect to ground, but vi is also image distance with respect to mirror. So both these velocities, velocity of object with respect to mirror and velocity of image is also with respect to mirror. These velocities are not with respect to ground. So while solving problem, this should be kept in mind. So we can write velocity of image with respect to mirror is equal to minus of velocity of object with respect to mirror. This is for plane mirror and also in direction parallel perpendicular to mirror. Okay, some of you will not understand this. Perpendicular to mirror. What does this mean? Here in the previous slide we have discussed, we are taking this direction. This direction is perpendicular to mirror. This direction is actually perpendicular to mirror. We are not taking this direction, like, or we can say, if assume that this is x axis and mirror is kept along the y axis, then we are talking about x axis. If mirror is kept along the y axis or in yz plane, then we are talking this velocity is in along x axis. So we are discussing direction perpendicular to mirror. Direction perpendicular to mirror. So this velocity is in the direction perpendicular to mirror. Like, if we take an example, suppose that we have a mirror like this, and this is direction perpendicular to mirror. Clearly we can see this is our mirror, and this direction is perpendicular to the mirror. Let's call it x axis and call it y axis. Mirror is kept in yz plane. That's why x axis is perpendicular to mirror. We all know, if any plane is in yz plane, then it will be perpendicular to the x axis. Now if any object started to move from here in this direction with speed 5 meter per second with respect to mirror, this velocity of object with respect to mirror is 5 meter per second. Now if image is here, so image velocity we have already seen with respect to mirror is equal to minus of velocity of object with respect to mirror, which will be minus 5. So if object is going in right direction, image will go in left direction. Image will go in left direction. It will become minus 5 meter per second. Or just no need to use this negative sign. We have already mentioned the direction here. Now somebody will think that you told that in the direction of rays will be positive, this direction should be taken positive. This is our choice. I mean, direction of rays is taken as positive, but if we are taking x and y coordinate axis here, we can say that this is our positive x axis. Sorry, this is taken as positive, so we can also say that this velocity is positive. Yeah, actually correct. This velocity of object is positive because it is going along the direction of image, so correct, no issue. So velocity of image with respect to mirror is equal to minus 5 meter per second. This is how we'll deal with these types of problem. If any object is moving in the direction perpendicular to the mirror, then image velocity will be equal in magnitude but opposite in direction to the velocity of object. But both the velocities should be with respect to mirror. Velocity of image with respect to mirror is equal to negative of velocity of object with respect to mirror. Right? See, let's take one more problem. Suppose that we have a mirror. We'll do two problem from this diagram. Suppose that again we have an object here which is moving in this direction with speed 10 meter per second. This velocity is given with respect to ground, velocity of object with respect to ground. And here image will be formed. So we want to calculate image velocity. So we all know velocity of image with respect to mirror is equal to minus velocity of object with respect to mirror. But here velocity of object is not given in mirror frame of reference. In the previous question, velocity of object was given with respect to mirror, but here it is given with respect to ground. So we have to convert this velocity of object with respect to ground to velocity of object with respect to mirror, so that we can use that in equation, because this equation is in mirror frame of reference, not in ground frame of reference. So we'll use relative velocity. I hope you all are familiar with relative velocity concept. If you are not, I'll discuss in 2 minutes. You will never forget. Velocity of any object A with respect to any object B is equal to velocity of A with respect to any frame of reference minus velocity of B with respect to same frame of reference. So first velocity of A with respect to B, so A minus B, AB, A minus B. So A with respect to some frame minus B with respect to same frame. Like we can write velocity of A with respect to B is equal to velocity of A with respect to sun minus velocity of B with respect to sun. We can also write velocity of A with respect to train minus velocity of B with respect to train. We can write it as velocity of A with respect to aeroplane minus velocity of B with respect to aeroplane. We can write velocity of A with respect to earth minus velocity of B with respect to earth. Any frame we can take, just keep in mind these two frames should be same. Here also it will be E. These two frames should be same. So this concept we are going to use here to calculate relative velocity. Sometime this velocity and this velocity will be known, so you will calculate velocity of A with respect to some frame, or sometime this will be known, so we will calculate this one. Like here, velocity of object with respect to ground is given. We want to calculate velocity of object with respect to mirror, and mirror is at rest. Velocity of mirror with respect to ground is equal to 0, means mirror is not moving, mirror is at rest. So can we write velocity of mirror, sorry, velocity of object with respect to mirror is equal to velocity of object with respect to any frame. Which frame? Here velocity is given in with respect to ground. So we'll take ground. Here I have written F, frame F, velocity of A with respect to any frame minus velocity of B with respect to same frame. So here we'll take ground frame, because ground frame velocity is already known. So velocity of object with respect to mirror is equal to velocity of object with respect to ground minus velocity of mirror with respect to ground. Now velocity of object with respect to mirror we want to calculate. Velocity of object with respect to ground is already given, 10 meter per second, minus velocity of mirror with respect to ground is 0. So it is 0. Here you can see that velocity of object with respect to mirror is equal to velocity of object with respect to ground, because mirror is not moving, mirror is at rest. But if mirror started to move, then here will not have 0. This 0 is representing velocity of mirror with respect to ground, and then we'll get something different. Velocity of object with respect to mirror and velocity of object with respect to ground will be different. So we have to be careful when mirror is also moving. If mirror is not moving, then no issue. Now velocity of object with respect to mirror is known, 10 meter per second. So we'll write velocity of image with respect to mirror is equal to minus velocity of object with respect to mirror, which is 10, is equal to minus 10. Okay, already minus 10. Clear? I hope you all are clear with this. Okay. Now the question is not asking velocity of image with respect to mirror. Whenever question is asking only velocity, it means with respect to ground. Always remember, in any question, if frame is not given, that velocity is asked in which frame, it means ground. Frame is not given means they are talking about ground frame of reference. So we'll write velocity. They are asking velocity of mirror image with respect to ground. Now velocity of image with respect to mirror can be written as C, velocity of image with respect to mirror can be written as velocity of image with respect to ground minus velocity of mirror with respect to ground, and this is minus 10, and velocity of image with respect to ground and minus velocity of mirror with respect to ground is 0. So actually velocity of image with respect to ground is minus 10. Again, velocity of image with respect to mirror is equal to velocity of image with respect to ground. Reason, mirror is at rest, mirror is not moving. That's why both frame velocities are equal. I hope now you understand these things. Let's solve one problem where mirror will also be moving. Now suppose that we have a mirror. It became really a mirror. ए भाई बुलेट तो बंद कर. Okay, this is a mirror. Bullets are so disturbing na. Okay, suppose that this is a mirror and this mirror is moving in this direction with some speed 5 meter per second, and we have an object here which is moving in this direction with speed 10 meter per second. We want to calculate, here we have image, we want to calculate velocity of image with respect to mirror as well as velocity of image with respect to ground. We want to calculate both of these. Now first of all, what equation we have to solve this problem? We have equation velocity of image with respect to mirror is equal to minus velocity of object with respect to mirror. This equation we have. This equation is developed in the mirror frame of reference, not ground frame of reference. And when this velocity is given, that this mirror is moving with speed of 5 meter per second, means this velocity is given in mirror with respect to ground. This velocity is given, just object is moving with 10 meter per second towards the mirror, means this velocity is in with respect to ground. Whenever frame of reference is not mentioned, take it as ground. Now see, velocity of image with respect to mirror we have to calculate. So first of all, when we'll have a velocity of object with respect to mirror, we'll put in this equation and calculate by multiplying with negative sign. But first of all, we need velocity of object with respect to mirror, because here given quantity is velocity of object with respect to ground. So we'll use the same this equation, velocity of A with respect to V is equal to velocity of A with respect to some frame minus velocity of B with respect to the same frame. So here we'll write again velocity of image with object with respect to mirror is equal to velocity of object with respect to ground minus velocity of mirror with respect to ground. Now velocity of object with respect to mirror is equal to, what is velocity of object with respect to ground? 10 minus velocity of mirror with respect to ground 5 is equal to 5 meter per second. Sometimes we try to calculate the relative velocity using our logic that okay, mirror is going away, this is going towards him, so 10 minus 5 or 10 plus 5. This is always confusing. So if you have lots of fluency, you have went through hundreds of problems related to relative velocity, then you can do by your logic. But if you have not, please use this equation once to verify. It is very bad to solve a problem wrong in the exam. So always be careful. Now velocity of object with respect to mirror is known. Now we can clearly write velocity of image with respect to mirror is equal to minus of velocity of object with respect to mirror, which is minus 5 meter per second. So object is moving with velocity 5 meter per second in negative direction, but not in ground frame of reference. Means if any object is sitting on ground, he will not observe velocity of image as minus 5 meter per second. If any person is sitting on mirror, means in mirror frame of reference, velocity of image is minus 5 meter per second. So for first answer, velocity of image with respect to mirror, we have calculated 5 meter per second. Now the second part of question is asking velocity of image with respect to ground. So let's solve that too. Now velocity of image with respect to mirror is known, and velocity of image with respect to mirror can be written as velocity of image with respect to ground minus velocity of mirror with respect to ground. And image with respect to mirror we have already calculated minus 5. Velocity of image with respect to ground we have to calculate, and minus velocity of mirror with respect to ground already given 5. Velocity of image with respect to ground is 5 meter per second towards right. Now we will calculate velocity of image with respect to ground is equal to minus 5. This will go here, plus 5 is equal to 0. Here you can observe velocity of image with respect to mirror is minus 5, while velocity of image with respect to ground is 0. Is 0. So actually image is at rest when it will be observed from the ground. If somebody will observe from the ground, he will observe that image is at rest. Image is not moving because image velocity with respect to ground we have calculated as 0. Clear? I hope this is clear to you. So this was all about in the direction perpendicular to mirror. We have studied all the direction perpendicular to mirror. Now let's take a direction parallel to mirror. Suppose that this is a mirror, and some object started to move in the direction parallel to mirror. Any object is here, and this object is moving in this direction with speed velocity of object. So image will be formed here at equal distance. This is u, so this distance will also be same u, I mean we'll represent it by v. Now if this object is going up with velocity vo, the image will also go with velocity vi, which will be equal to vo. Velocity of object and velocity of image will be equal. Why? Just do this experiment. Suppose that there is a big mirror on one of the wall of your room. Now if you start to walk parallel to the wall, your image will also walk with you. It's not like you are going in the right direction, image will go in the left direction. Both will go in the same direction. But if you will go away from the mirror, the image will also go away from the mirror, but in opposite direction. So always remember, the in the direction perpendicular to the mirror, image and object velocity with respect to mirror will have equal magnitude and opposite direction, while in the direction parallel to the mirror, object and image velocity will have equal velocities in terms of both magnitude as well as direction. And when we are talking about velocity of image and object in the direction parallel to the mirror, mirror velocity will not be important. Even if mirror is moving, image and object will move in the same direction. This is not going to be important. But here in the first case, whether mirror is moving or not, it will be very important, because this velocity is measured in a mirror frame of reference. See, here we have written with respect to mirror. This is the most important term which you all have to keep in your mind. Most of the students do mistake here. They take all the velocities with respect to ground. I hope you understand this. Both the direction parallel to the mirror, velocity will remain same. Perpendicular to the mirror, velocity will be in opposite direction. Means object and image will have velocities equal in magnitude, opposite in direction. Now suppose that we have a mirror. Again, this mirror is in YZ plane. Means YZ plane will be perpendicular to the x-axis. YZ plane will be perpendicular to the x-axis. This is x-axis, and this line, this mirror is in YZ plane. Means this mirror is passing through y-axis and z-axis. So, I mean, this plane is perpendicular to your screen wherever you are seeing this lecture on mobile, tablet, smartphone. The plane in which mirror is kept is perpendicular to the screen. Now, if we have any object here, object started to move in this direction with speed 20 meter per second. 20 meter per second. Now, the question is asking what will be velocity of image with respect to ground. So, since velocity of a mirror with respect to ground is already 0, means mirror is not moving. So, no need to bother about whether velocity is with respect to ground or mirror, because velocity of image or object with respect to mirror will be same as velocity of image or object with respect to ground. So, frame of reference is not important when mirror is at rest. If mirror is also moving, then frame of reference will become important. Now, what we will do? See, this velocity is neither in parallel to mirror nor perpendicular to mirror. So obviously we'll break this into two components. One component will be in parallel direction, one component will be in perpendicular direction. Assume that this angle is 37 degree. So first we'll calculate its component along the perpendicular direction, which will be 20 cos 37. Cos 37 is 4 by 5. So 20 cos 37 is 4 by 5. So 20 into, it will be 20 into 4 by 5, 16 meter per second, and the perpendicular direction is going to be 20 sine 37. Sine 37 is 3 by 5. So 3 by 5 into 20 is equal to 12 meter per second. So if this velocity is in a plane, this 20 meter velocity is in, suppose that xy plane. Take this axis as y axis. So our laptop screen is xy plane and mirror is in yz plane. Z axis is perpendicular to the screen and mirror is also perpendicular to the screen passing through y axis and z axis. Now velocity, first of all, they are asking velocity of image with respect to mirror. So first of all, we have to calculate the velocity of object with respect to mirror in term of. So first of all, we will calculate velocity of object with respect to mirror. So we can clearly see here velocity of object have two component, one along the x-axis in the positive direction, which is 16 meter per second I cap, x-axis we can write I cap, and one perpendicular to the mirror in the y direction. So we'll write plus 12 j cap. And if we same velocity is with respect to ground too, velocity of object with respect to ground. Why? Because mirror is at rest. If mirror is moving, then these two will not be equal, but these two are equal. Why? Because mirror is not moving, mirror is at rest. Once this velocity of mirror with respect to ground is non-zero, then these two will not be equal, but they will be different. Now velocity of, we want to calculate velocity of image with respect to mirror. See, we have to calculate from velocity of object with respect to mirror, obviously. So here two direction are there where the velocity of object have component one 16 meter per second x axis or parallel to mirror, which we already know that it will be reversed. Means if object velocity in the direction perpendicular to mirror is 16 meter per second with respect to mirror, image velocity will be minus 16 meter per second with respect to mirror. So velocity of image will become minus 16 I cap. Why this direction is reversed? Because x axis is perpendicular to the mirror. So x component of velocity of object will be reversed and we'll get x component of velocity of image. Means here we can write velocity of, actually we can write velocity of image with respect to mirror, x component is equal to velocity, it will become messy. Okay, first let me write this so that you all can get it in a better way. See what I am trying to say. X axis is perpendicular to mirror. So velocity of image with respect to mirror, x component will be negative of velocity of image with respect to, sorry, object with respect to mirror, x component. Where velocity of image with respect to mirror, y component will be equal to velocity of image with respect to mirror, y component. Object with respect to mirror, y component. So along y direction, x velocity of image and object will be same. Not only in y direction, z direction also will be same, because z is also parallel to the mirror. Mirror is in y z plane, means y axis and z axis both are in the mirror. Now we can solve this question very easily. Velocity of image with respect to mirror, so x component will get reversed, so it will become minus 16 I cap, minus 16 I cap, and plus this will remain same, 12 j cap. So this is the velocity of image with respect to mirror, and same will be the velocity of image with respect to ground too. Velocity of image with respect to ground will also be same as velocity of image with respect to mirror. Why? Because mirror is at rest. Mirror is at rest. At rest. If mirror started to move, then if mirror started to move, then object this velocity of image with respect to ground will not be equal to velocity of image with respect to mirror. But if mirror is at rest, both is going to be equal. I hope now you understand this. Now let's take one more example where mirror will also be moving. Assume that we have a mirror. Again, this is along the y-axis, mirror is along y-axis in yz plane, and this is x-axis. And let's take the same question. This is going in this direction, it's 20 meter per second at 37 degree, and mirror is moving in this direction with speed 5 meter per second. Now when you will calculate velocity, see all these velocities are given without any frame, means all these velocities are given with respect to ground frame. Now we have to write the vector form. Velocity of a mirror with respect to ground is equal to 5 I cap. This mirror is going with respect to ground in with 5 meter per second in I direction. Velocity of object with respect to ground is given 20 meter per second, but again we have to break in vector. We have already did. This is 16 and this is 12 meter per second and this is 16 meter per second. So velocity of object with respect to ground will become 16 meter. It will become 16 meter per second plus, sorry, why we are writing meter per second here, just write the vector form, 16 I cap plus 12 j cap. Now we have to see, we cannot use velocity of mirror with respect to ground or velocity of object with respect to ground. We are going to use velocity of mirror with, sorry, velocity of object with respect to mirror. So we have to calculate it. And velocity of object with respect to mirror, we already know velocity of object with respect to ground minus velocity of mirror with respect to ground minus velocity of mirror with respect to ground. So velocity of object with respect to mirror is equal to velocity of object with respect to ground is 16I plus 12j and minus mirror with respect to ground is 5I. So actually velocity of object with respect to mirror is 11I plus 12j. 11I plus 12. Now we already know that if velocity of object with respect to mirror is 11I plus 12j, velocity of image with respect to mirror will be how much? Again, mirror is perpendicular to x-axis, so x coordinate will get reversed when we'll convert object velocity to image velocity with respect to mirror. So it will become minus 11I cap plus y component will remain same because y axis is along the mirror, not perpendicular to mirror. So y j 12j cap. Now this velocity is with respect to mirror, not with respect to ground. So again, we have to write velocity of image with respect to mirror is equal to velocity of image with respect to ground. Sorry, yes, minus velocity of mirror with respect to ground is equal to, what is velocity of image with respect to ground? We have already calculated. Okay, right in next line. What is velocity of image with respect to mirror? We have already calculated here. So minus 11 I cap plus 12 j cap is equal to velocity of image with respect to ground. We want to calculate that, we want to calculate minus velocity of mirror with respect to ground 5I. Now this 5I will go to left hand side and we'll get velocity of image with respect to ground is equal to minus 5I, I will go this side, so we'll get minus 6I plus 12 j cap. This is the velocity of image with respect to ground. I hope there is no calculation mistake. Clear? So minus 6I plus 12j is the velocity of image with respect to ground, and minus 11I plus 12j is velocity of image with respect to mirror. So when mirror is moving, things will change. Velocity of image with our object with respect to ground and mirror will be different. But if mirror is at rest, same. Frame of reference, no need to be taken in care. I hope all the velocities of image and object related to mirror is clear to all of you. You all can solve these types of numericals. Uh, you can join Telegram if you have any doubt. I am pasting the QR code here. I'm not whatever code is there. I am pasting that QR code here. You can scan this and you can ask any doubt on the Telegram. Please ask if you have. If I have free time, I'll clarify. Thank you for watching. We'll make one more lecture that will be little longer, or might be two lecture of 30 minutes to explain what will happen with velocity of image in spherical mirror. Spherical mirror is little more complicated than plane mirror, because in plane mirror velocity of object and image with respect to mirror have same magnitude. Their magnitude will not change, only direction will change. But in spherical mirror, their magnitude as well as direction can change. So spherical mirror are little more complicated. In the next lecture we'll discuss about that. Keep watching, keep learning. Thank you. और दिल करे तो सब्सक्राइब करो.